Alright, we're back. I think my battery's got just enough time to do another video here. Okay, so we looked at our, just got done looking at all those bushings and stuff. Now we're going to look at our oil pump. So the oil pump had a lot of grit running through it, but I'm not seeing much wear. So I think we're going to squeak through on that all right. You can see the wear mark on the one side, but not over here. That's how the outside is, what we care about. You can see there's a line where it had a piece of crap went through it, but it's pretty faint. Should be good. The gears show a lot of evidence of stuff running through them, but no gouges. So you can see the color on the gear tooth, but the tooth is straight and not worn or chipped or broken or anything weird going on. So they look all right. So you're looking at the top of the tooth. Should be a nice relatively sharp edge machine, and then you look at the flanking on the side and you're looking for anything on that also. That's what you're checking. Okay, so we got an idler, and then we're checking to see how much protrusion we have. Nothing. Here's the other gear. Nothing again. Not a damn thing. And here's our shaft. And that gear does not want to go on there at all. But that side. Looks on that side. Close enough. No contact on the gear. So it's negative clearance or 0. Feels like 1 thou maybe down max. And we look at our tooth clearance between the teeth. See how loose those are? Pretty loose. Someone's making noise back here. I don't know what's up with that. Maybe if you turn the darn thing off, it wouldn't make noise, right? Okay. Alright, so the teeth are nice and loose. So you can see the tooth flanking going back to back in there. You hear it too. So it's worn out, brand new. What a shocker. It's hard to measure clearance between here. If you got a real piece of thin shim that went in there like a thou thick, you can tell something, but that's about all you can really do to check it. So the problem with this is the gaskets are usually 8 to 12 thou thick. They average about 9.5 to 10. And we have no protrusion, so that means you're going to have that much clearance between the gear face and this, which means you're going to have a lot of oil leakage. Because obviously if you have a gap sticking up like that, the oil rushes straight through and it doesn't make any pressure. So you want to have basically 1 to 3 thou clearance. I like it 0 to 1 at best. 1 to 2 is okay. 3 is alright. More than 3 I don't like. So right now we're going to have the thickness of the gasket. The gaskets, like I said, made these days are thick. Back in the day there were some gaskets around 4 to 5 thou thick. But they're few and far between. I'm coming up with them these days. It's hard to do because those things are 30 years old now. But I have some floating around, so I'll try to do what I can do. Otherwise this has to be ground down. So you can sand on it, but it won't be very flat. It'll probably leak and it won't be even. So it needs to be actually ground down. So the pin comes out and you grind both surfaces down to get whatever clearance you want. So you get your gasket, you measure it, and then you grind it down until you got 2 thou clearance. And the gasket should squeeze a little bit and you're good to go. If you screw up, you come back and sand the tooth away, the gear a little bit to get some clearance. If you want to push your luck, you go down to 1 thou clearance and then go that direction and try that. And then you really get close. Like so you hand fit these until they just don't drag. When you tighten the pump on the motor full tight, the pump should turn freely. If it doesn't, it's binding. You need to fix it. Okay, so that's the return sump gears. So now we go over to the pressure side, which are the thin ones. And same thing. There you see the clearance. Put our shaft in there for alignment. You see the clearance in there? Definitely loose. And we check our alignment. Okay, I'm just catching the tooth there, which is good. That means it's sticking up something. That's about a thou maybe. This one's just barely touching it. Okay, so we got about 1 thou stick up probably. If you had more than that, you could feel it. The scale would be off the surface right there, and you could have something. Yep, actually you do have a little bit right there. See the clearance? So if you put a feeler gauge under there, you could check that and see what you really had. Looks like we got a couple thou protrusion. Yeah, so if I can come up with a 5 thou gasket, it would be a really nice fit. Yeah, I don't know if I can come up with that, but we'll see. I should have some old Excel gaskets when I used to make them, and I think they were 5 thou thick, so that would work good on this side. The other side, they were definitely not sticking up at all. So this side here we might look out on. This side over here, not going to be so lucky. Unless I was reading that wrong. So I'm on the pin. See, when you're on the pin, you got clearance. See, when you're on the gasket surface, see, there's no clearance. These are definitely not sticking up on this side. We probably got a couple thou sticking up on the other side, which is good. So that's a helpful on that part. Alright, so this bike has a belt drive on it, so we're going to probably make sure we shut this oiler off. This oil is made to put oil flow into the breather cavity here. And it dumps it into the passage. It goes across and lubricates your chain over here. He's got a belt, no lubrication, so we're going to make sure we plug this thing up. You can JB weld that solid, you can weld it up solid, you can put a pin in there, do all kinds of things. This, you can see how the threads are really horrible. Oh, look at the screw threads there. They're pretty flattened out. Yeah, those are horrible. Theoretically, when you bottom this out, it doesn't let any oil through anyway. But as loose as this thing is, yeah. So I'll probably figure out which one of these two holes feeds it and go in there and put a pin in there and plug it. I don't like welding on these things, but putting a pin in there and lock that in is just fine. I don't know what that hole through there, I've never seen that before. What the hell's that all about? That must be how they're feeding it. That must be the feed hole to the gallery. Nice. Oh, that's on the return side. That's on the return pump. So it looks like they're feeding oil into the primary breather through the feed gear shift. And then it goes to the body into the case. Okay. Well, either way, if I plug up one of these two holes here, it will plug it. One's probably a dowel pin. Alright, what am I doing wrong here, you dumbass? Okay, that's obviously a dowel hole right there. Damn hole is so loose, I don't know what the hell it's even doing. That dowel pin ain't doing anything. Cosmetic. The studs are aligning it. Okay, so this is your dowel hole, so this is the one you plug. So I have to make a rod, put it in there with Loctite on it. That should plug up that hole completely and eliminate oil go where we don't want it to go. Hopefully. Because that's feeding this hole right here, which is going to where? It's going up to here, it looks like. Where's that going to? Oh, that dumps right into the cavity. Right there, and dumps it. There should be a hole on the bottom down here that sucks it out. That one sucks it out. This one fills it. This one goes in and dumps it into it, so it puts extra oil into there. So if your rings aren't bad enough already dumping oil in the motor, that dumps more into there. So it loads up this system here. It overloads the system, so I'm not sure how good that really works. Kind of a crappy way of doing a job, but oh well. Alright, so I'll double check all this stuff when I plug it, make sure I'm doing the right thing. I try to plug it up on the starting, not the ending. But that'd be pretty hard to plug that little small hole there. So that means I'll be plugging the secondary hole out here. You can also plug it out here too. You know, anything you do to plug all these holes, we'll plug it. So either that one, this one, doesn't matter where you plug it. So once again, if you plug it out here, it's permanently plugged. If you plug it out here, when you change the pump, it's open again. So the place to plug it is probably over here in the case. And then that'll be a more secure location. It'll actually plug it for good. So I'll probably plug the case instead of the pump, but I usually plug up the pump because you know it's plugged. Some guy might want to run a stock chain system on here, and he will not know why it doesn't work. And once I plug that, you ain't getting it out. So I'll probably plug the pump. Okay, and this is an early style non-rotor pump. So this is your 30s pump. Goes like that. This is your 40s pump over here. Has a rotor vane. Goes like that. You also see the pump is different. Pre-war, post-war. And here's the rotor vane, which is a piece of crap that Harley quit using. So right in there. It's driven off the oil pump gear here. That's just like that. This one just goes directly under there and doesn't have anything else feeding it. So it's lower profile. And you don't have a separate piece here to crack and break. You have it fixed on the cover, so the cover will break. So this is a lot thinner. But they use the same gears. Even though this pump is a lot bigger looking in the real world, it's the same size pump. Look how thin it is here. Look how thick it is over here. So don't go by looks. Looks like a small pump, but in reality it's the same size. It takes the same gears. They ran these same gears up to 52, I think. And then they started playing around with a different thickness on this one. These stayed the same, I think. They had different idler holes. They started screwing around so you didn't mix gears up. They had a lot of stuff they're screwing around with. So this is a 47 pump. And like I said, this is an aftermarket motor. It's not stock, so this is a 30s pump. So I think the rotor came out in 40. I'm not sure. Probably when it came out with a 74-inch motor. But, anyway, they're different. It goes over there. Same gears, same shaft, same gaskets, different parts. There you go. Actually, gaskets are different too, probably. That's a different gasket. Alright, that's it for this one. So this one's going to need all new bushings in it, and the other parts look alright. Until we hone the cases, we don't know what they're going to be, so I got to hone these all out, and I might have to replace the bushings to start over, and I'll need to get new shafts too. So it looks like both these motors are back on hold for some parts. So order some more parts up. Alright, that's it for that.